In this course, we will not cover what a loop is, why we use a loop, what a variable is. Such details we are not going to cover. It is assumed that you all have some basic knowledge on programming. That is the prerequisite. You already have completed C++, C. So such a level of basics we will not go into. How a loop works, or how why you use a variable, what's a constant, these things. So if you really have some issues in those areas, I kindly request you to go back and study those concepts. It's very important, because without those fundamentals, you will not be able to follow what we are handling here. And the syllabus also, I shared with you the syllabus in the last class. I'll be putting this up in the course page. So as I told you in the last class, we are going to talk about Java basics, features of Java language, JVM bytecode, Java source file structure, basic programming constructs, arrays, and loops and string packages in the first unit. They have allotted only 4 hours for this. Second unit is going to be fully about object-oriented programming, objects, classes, constructors, polymorphism, abstracts, and interfaces. So, and the third class is on exception handling and multi-threading. That is the third unit. Fourth unit is on files and collection framework. Fifth unit is on GUI programming using JavaFX. And sixth unit is on servlets. Seventh unit is on JSP. Finally, eighth unit, industry expert talk. So that's our syllabus. I'll share the syllabus with you, the course page. And agendas for today's class. What is the agenda for today's class is why we learn Java. That is the first question I had in my mind when they asked me to take Java. I already know C++, maybe something of C++, something of Python. Why should I really go and learn Java? What it's going to offer me was the first question I had in my mind. And history of Java, not so much. We'll just see the several versions of JDK and how Java evolved. Java environment, we have to understand behind the scenes what's happening when you submit code. Java installation on Windows. I'll tell you, if you are new to Java, you have to first install Java on Windows and how to use IDEs so that you can create programs easily. We'll see running our first Java program. We'll not stop with that. We'll go through some of the basic constructs like if-else statements, loops. We'll also take up some exercises at the end of the class. We'll be looking at variables, operators. We'll be moving through these things quickly. Okay. So why Java? The important fact that was convincing is it's portable and it's platform independent when compared to C and C++. Your C and C++ code is machine independent, so you can't really port it across different platforms. Whereas Java has come out with an idea of making it a platform independent, the bytecode concept. So we'll be looking at what bytecode is and why we use that when you're talking about the Java environment. And they say it's secure, robust, architectural, neutral, and it's also interpreted. So these are some of the Java language features, and I was very much convinced with respect to platform independence. So that and history of Java, this guy James Gosling is called the father of Java. He invented Java in 1994, and he created the original design of Java and implemented the language, original compiler and virtual machine. So from 1994, Java has gone through various revisions. So when you're going to work with Java, what you need on your systems is you need a Java development kit that you have to install on your systems. What is Java development kit or JDK? What it contains is it contains a Java runtime environment plus the development tools for constructing and compiling your code. So JDK is what you have to download and install on your systems, and we'll take a look at the contents of JDK. JDK has got these two things. One is the development tools, the compiler, debugger, and tools for monitoring your code. The Java runtime environment consists of the Java virtual machine and library files. So when you install JDK, you're going to get the entire thing out there. So we'll take a look at what is this JVM, what is this JDK and things like that. I'll go to a white screen. From here, I'll try and explain things out there. So you'll be writing your first program in Java, right? Maybe you create a file in TextPad, in Notepad. You write it as first.java. You create a source file, and then you're going to hand it over to the Java compiler. So compiler is going to take it up, and what it's going to do is it's going to convert it to a bytecode. Bytecode is an intermediate representation of the code. It's not machine dependent. So you're converting a Java source file to a bytecode, which is machine independent. And this bytecode will be given to your Java runtime environment, JRE. So all these things, the compiler, debugger, monitor, everything comes under your development tools. Whereas this bytecode, which is not machine specific, is given to Java runtime environment. What Java runtime environment consists of? Java virtual machine plus all the class libraries. So you'll be using a lot of Java libraries for input, output, formatting, processing. So all those libraries plus your Java virtual machine is going to form your JRE, and it also consists of two more things. One is the class loader and bytecode verifier. I'll tell you what these things are. So your bytecode comes in, a dot class file gets created from the dot Java. When you compile it, a dot class file will be created from this dot Java. So you're going to get your bytecode as a dot class file. This dot class file will be given to your Java runtime environment, right? First thing is the class loader will load this class file into on the memory. Loading the class file to memory is the class loader's work. Bytecode verifier will verify whether the bytecode has got any security vulnerabilities, any security issues. So that is the role of bytecode verifier. So when it clears the bytecode verification process, the Java virtual machine will use an interpreter to interpret and execute the bytecode onto your system. So Java runtime environment is machine specific. What do you mean by machine specific? So if you are using a Windows system, you have to 64-bit Windows system, you have to download that corresponding JRE for your system. If you are using a Linux and a different platform, you have to download that particular JRE. So this JRE converts your machine independent bytecode to a machine specific instruction. Finally, that is interpreted by your JVM and given as an output. So what they say is Java is both compiled and interpreted. First it gets compiled to a dot class file. Next it gets loaded, verified, and then interpreted. So from dot Java to dot class and then to the final output. So that is the architecture behind or the environment wherein your program runs. Let's take a look at this JRE environment. This is from docs.oracle.com, the website which gives you the documents. So this is what I was talking to you about, class loader and bytecode verifier plus all the class libraries of Java. Once when these two processes are done, it's given to the interpreter for reading it line by line and executing the output. So which gets executed is the bytecode. So with that basic definition or a basic understanding of what environment we are going to work on, what kind of revisions happened to your Java development kit so far? From 1995, these are the various several versions available for your JDK environment. Right now, I have installed JDK 8 in my system. I already used JDK 8 for a previous class last year, so I have not upgraded it to JDK 11 or 10, but it's fine. I'm going to use JDK 8 for all my coding purposes. So where can you go and download? Yeah, uninstalling previous versions. So if you are using Java, you have to check the version of your installation. How can you check the version of your Java? What you have to do is you just go to command prompt. I think you have to give Java and then hyphen version. So it gives me which version of Java I am using. It's 1.8, that is JDK 8. So you have to find if you have any previous installations of Java. Say you are planning to use JDK 11, you have 8 installed or 7 installed. One thing you have to do is you have to keep in mind that you have to go and uninstall older versions. Why you have to uninstall older versions? Because of security risks or any security reasons. It's good to uninstall older versions before installing a newer version. So how will you uninstall an older version of Java? Just go to control panel, add or remove program, search for that JDK and uninstall it. That's it. And then you can go and install any newer version of Java. I will say you use JDK 8 so that we are all in sync with any issues that we get in our class or labs. So that is where you down. No, first you uninstall all the previous versions, any older versions you have. Where you can go and download. This is the link I have given. You can go and download from this link, and you'll be able to see the various versions there. Let me check if I can really. If I am connected to net, whether can I see that? I think this is for the Windows platform because I was downloading it for my own system. So I've given the link for the Windows. You can search if you're using Linux or some other platform. Please download that particular version for your system. That's what I wanted to tell you. So how do you install it? Just download that file. Go to your place where you have put all these files, and then you search for that particular file. Click on it. You will be able to run your system. So here is this JDK 8U71 Windows 64-bit version. Just click on it. It gets installed. And then again you can run your Java version to check whether you have been updated or upgraded to the latest version. So that's how you install Java on your systems. If at all you need the software from me, you can give me your pen drives. I can also share the JDK file so that you can install it on your systems. So JDK 8 is what we are going to use for our code. So now Java is installed. How to write a program, how to run a first program is the next question. So to run a first program, what I did was I went to my folder, created a programs folder so that I can have all my programs here. And in this folder, I'm going to save all the programs I'm going to run. So I opened a new text file, something like this, new text file. And then I'm going to type my code here inside this file. So let me type one simple piece of code. So I already used, see in Java the thing is, everything is a class. There's nothing without a class in Java. So you put a class, inside that you'll have this main function. We'll come to all these things soon. And then you'll have an argument of strings, an array of strings. What we are going to do is we are just going to print something to the user. A simple print statement. The first thing that we always do is hello world, we are going to print, right? So that's a simple small program which is going to print hello world to the user, and we are using a notepad for this, nothing big. And you have to save this file save as. You have to save this file in the programs folder. I'll give it as third.java. The extension should be .java for your file, and then you save it. That's it. So you have saved your program in one of the folders of your choice. The next thing is how to use our Java compiler on this program and compile it to a .class file. So for that, what we are going to do is we are going to go to our command prompt again, and what I am showing here is nothing but how to execute a Java program from your command prompt first. So let's go and improve the font size here so that you guys are able to see. And what we are going to do here is we are going to traverse to our F drive wherein I have my program folder. So in my F drive I have my programs folder. This is where I store all my programs. So I'm going to go to this particular directory, and from here I want to run my program. So for this I should somehow map the Java compiler which is downloaded by default in the Java compiler gets downloaded in your C program. It will ask you for the directory. By default it goes to C program files and then Java. So you can see the versions of JDK installed, and when you just browse in to JDK bin, you can see there is something called Java C. So this is the compiler that we are going to use for compiling a code. So what we are going to do is we are going to just copy this path, and we are going to set path here. That is set path is equal to percentage path. This is one command to set the path, percentage semicolon, and copy paste the path. So we are in the folder where we have saved a program. We are giving the path where our compiler is. We are setting the path for that. Now once when it is done, we have to go ahead and compile our Java program. How to compile this? Java C, and then you give the file name, that is third.java. Yeah. When you run Java C third.java, if you have any compilation issue, say you missed a semicolon, you missed a quotation, you'll get that error here. And you want to run this, you just say Java and then third. So your output hello world is getting printed to the screen. You know now, right, how to run a simple piece of Java code from your command prompt and using a text file. But obviously, when you use a text file, there are certain problems. Like what kind of problems you face while you're using a text file? The thing is, when you're using a text file, it's very difficult to get some auto suggestions, or you make some mistakes. For instance, it's case sensitive. If I give strings to be small s, it's not going to tell you there's an error. It's not going to auto complete anything, and typing and no indentation, everything you have to maintain it on your own. And when you say in Java, you're not going to put all the code in one single file. You're going to write many different classes in many different files, and all these classes will interact with each other to form a system. So maintaining such things with just pure text files and developing a project is a very tedious process. So what we do is we normally we use some integrated development environments to run our code to develop our projects. So what are these IDEs, integrated development environments, for developing large scale projects wherein you have multiple files, you have to integrate it to the database, you have to do a lot of things. So you can use an environment wherein you can code. Code becomes very easy. So popular IDEs, these are the 10 open source freely available IDEs for Java. Most popular is NetBeans and Eclipse, and other things follow. You can use any one of them, but I am going to use Eclipse for our demonstration purposes. So Eclipse will be the IDE that I'm going to use, and how you download it. Again, Eclipse has got so many different versions, man. For the past several years, you have Eclipse, Photon, Oxygen, Neon, so many versions of Eclipse. And where you can go and download Eclipse is, I given the link here. Just click on the link. You'll be taken to the place where you can download Eclipse, and click on download. It gets installed on your system. Directly it gets installed on your system. So after you install Eclipse, you'll be able to just go and click on the desktop icon and invoke Eclipse. So you're just going to click on Eclipse, this icon, and just start your IDE. So it's going to, this is the IDE. Or this is the interface wherein you're going to write all your code. And how you start off with writing projects. As I told you, projects will have so many files. So many different classes. So what you can do is you can go to File, New, and you can click on Java project, and then you give a project name. See, I have already created a project here, so you can click on you can give a project name, any project, say Java projects. And then one important thing is here you have to go and select your Java execution environment. What is the JDK version that you're going to use? So here, when you install Eclipse, it automatically detects the install JDK version runtime environment, and it just maps it here. So it says Java SE 1.8. So that's what I have installed. If it's not able to find your implementation of your Java, the JDK, it's going to ask you to browse to that particular location. So that, because Eclipse should have all those information about the environment that you're using to run your code. That one thing is it's automatically detected, and next you click on next, and then you click on finish. Your project is going to be created. So once when the project is created, what you're going to do is you're going to go to your project. So I already created a project here. Just right click on the project. You right click and then you go to a new Java class. So once when that is done, say here you're going to get this kind of an interface here. So it's going to throw this default code for you. It's going to throw the default structure for you from where you're going to start coding. So this even import statement also I will delete. So this will be your default structure for your. So as I told you, the idea is make a life a little bit easier because it gives us with that default structure, autocomplete suggestions and things like that. When you get into errors, it will suggest you where the error. So every Java program will have a class. Please understand that everything that is put inside a class. So first you create the class, and then inside that you'll have methods for your class. And to run your Java program, it's mandatory to have a main function, main method. Like in C, without main, your code is not going to execute. The same way like in C++. So in the main method, we have some keywords here: public, static, void, main, and an array of strings passed as arguments. We'll come into these details soon. But this is the basic structure of your Java program. Any program you write should have the class. Within that, you should have the main function. Without the main function, your code will not execute. Please understand that. So that is our first thing, and we already seen how to write a first print statement, right? Let me go back to my slides. Let me check what else we have here. So that is our first simple Java program structure. Please keep in mind it's case sensitive. If you give a small s instead of a capital S, it's not going to work. It will throw you some errors. So here string is a capital S, system S is a capital S. So how you get all these things is only through practice. You keep typing every line of code, so you'll not miss all these things. We'll directly jump into Java data types. So you know what a variable is. To hold a value in memory, we are going to declare a variable. And what are the several data types available? We have Boolean, character, byte, short, int. So all these things are used for storing an integer value. Byte, short, and int. Only difference is number of bytes it holds in memory is different. For a byte, normally it is only it's 4 times lesser than the int. So you want to save some memory, you can use a byte. Short takes 2 bytes. Integer takes 4 bytes. Float and double are used for storing fraction values or any decimal point values. So you're going to use float. It takes 4 bytes. Double takes 8 bytes. There's one more thing I want to tell you here. Character normally should take 1 byte, right? In C++, it takes 1 byte. But in Java, a single character takes 2 bytes because Java is not following the ASCII standard. What is an ASCII standard? It's an American standard code for information interchange, right? So you map your characters to some kind of numbers. You map A, B, C, all these special characters to some kind of numbers so that you can internally handle them. So ASCII is 8 bits in length, but with ASCII the problem was we cannot map all the characters of all the languages using ASCII. Maybe English alphabets and some special characters you are able to map. But with Unicode format, you can encode even Russian or French or any kind of alphabets, Arabian alphabets. So you have 16 bits of memory available to map characters in Unicode. So Python also uses Unicode 8, I guess. So Unicode format is adapted in Java. That's why for a single character, they're using 16 bytes so that the number of bytes, number of characters they can map will be very huge here. You can map almost every character on this. So Boolean is again true or false, it takes 1 bit. So you can go and declare any variable. Variable naming conventions, right? Give some meaningful names, use Pascal casing or camel casing, and that's the industry standard. So you give some, say, second number, something like that. You separate variables, with an underscore in between so that it's more readable to. I mean, not separate variables. Give names such that it's more readable. So in second number is equal to 2. So you can directly create variables like this, very similar to C. So if you want to create and store a float value, float number is equal to 3.5. Directly we can go and use values here. Okay. So that's all about our variable declarations. We'll move to operators in Java. C++, Java is very easy. The thing is, most of the operators we have learned. Unary operators, postfix and prefix. Can you remember? I plus plus and plus plus I. What is the basic difference between a postfix and a prefix operator? So, what are the operators? First of all, you have arithmetic operators, shift operators, relational, bitwise, logical, ternary operator, and then assignment operator, unary operator. So you have this I plus plus is called postfix, or plus plus I is called prefix. So what is the basic difference when you use I plus plus in an expression? Will the assignment happen first and then the increment happens next, or the assignment happens after the incrementation? Yes. When I do k is equal to I plus plus, will the assignment of I happens to k first and then the increment happens? That's what is the rule, right? When I use plus plus I, the pre increment operator, first it gets incremented, then the assignment happens to k. So these things we have already seen in our other courses. The same condition applies here. Arithmetic, star, slash, and modulo operator, plus, minus, left shift and right shift operators. Can you recollect what do you mean by bitwise left shift and right shift? So you're just going to move the number of bits either left or right based on the condition. You're going to use the same operators here. Similar to what we have used in C. We'll come to what is instance of while we talk about objects and classes. And bitwise and or and exclusive or and not. What is a bitwise operator? Bitwise operator, you're going to say you're going to give 10, it's going to work on the bit level. Say it's 8 bits 000 100, something like that. So, what is an AND operator? When you have two numbers, when will you get an output to be 1? If two numbers are in binary, on both are ones. When is an OR operator going to work? Only when one of the, at least one should be a 1. What is an XOR then? When both are 1, the output will be 0. Only when at least one is 1, it's going to be. What is a NOT operator? We have a NOT operator here. I don't see a NOT operator. Okay, logical and OR, right? If A is greater than B and A is greater than C, that is the logical AND. What is the logical OR? If A is greater than B or A greater than C. You learn Python or you learn Java to get placed. So that comes the OR operator. You complete the course and you complete the course without any arrears to go into placement. So that's the AND operator, right? So see, that's what I told you. We're not going to dwell into the depths of operators. These are very basic. We have already covered in our previous base class. Assignment. taking the value of one variable, assigning it to another variable. So what kind of assignment operators you have? Everything that is available in C, plus, equal to, equal to. So we used all these assignment operators in C, the same kind of assignment operators C and C++.